All right, so let's take a look at this, right? For the isobaric expansion AB, there's a lot you can calculate for isobaric expansions, right? The first is work done by the gas. So the work is pressure, change in volume, right? So the pressure here is 5 times 10 to the fifth, right? And it stays that pressure for the whole process, right? The change in volume is final minus initial. So 8 E minus 3 minus 2 E minus 3. Okay? Well, let's calculate that. What is that? It's going to be a positive work, right? Because it expands. So 5 E5 times parentheses 8 E minus 3 minus 2 E minus 3. And I get 3,000. And that is the correct answer. 3,000 joules, right? Okay, so calculate the change in internal energy of the gas. Well, there's two ways to do it. We know that this is 400 and this is 1,600. Okay? We also know the pressure and temperature at B, so we could figure out the number of moles. Right? So moles is going to be PV over RT. Right? And if we plug this in, if we plug in the pressure, so I go 5E5, right, times the volume, times 2E minus 3, right? And then I divide by R, so I divide by 8.31, and divide by 400. I get that the number of moles is 0.3008. Okay? So I can find the change in internal energy using this. So change in internal energy is 3/2 NR change in temperature, right? So it's 3/2 0.3008 times 8.31. And then our change in temperature from 400 to 1,600 is 1,200. An increase, right? Positive 1,200. So let's try that. That number times 3 divided by 2 times 8.31 times 1,200. I get 4,500, which is a strangely round number for using this thing here, right? And you're like, and that's the correct answer, right? This is not how I do it, though. Remember that change in internal energy, since nRT equals PV, if just one thing changes, the pressure or the volume, you can do this. It's also 3/2 P delta V. Well, we already know P delta V is 3,000. So 3/2 of 3,000. Why, that's 4,500 without really breaking a sweat, right? There are times when it's kind of ideal to get the number of moles, right? But sometimes it just gets in your way. So anyway, that's what I would do, right? So now the final thing is, what's the thermal energy transferred to the gas? That's Q. Okay, it's a synonym for Q. So remember, Q is delta U plus work. So do you suppose we're going to add this number to that number? Okay, so delta U is positive 4,500. And then the work is 3,000. Do you want me to explain this any further? Is that 7,500 joules? Woohoo! Right, so this is, by the way, this is the QH for this thing, right? That's the heat that flows in. Because see here, heat flows out and heat flows out, right? Heat flows in here. So this will be our QH when later we want to figure out the efficiency of this thing, okay? All right, that's all we need to do.